Welcome students. Today we are going to see revision on topic combustion and flame. See, in the introduction part we discuss for the different purposes we are using the fuel. For vehicles we are using the fuel, for domestic purpose we are using the fuel, then in industries, then for the trade industries, or for different kinds of the purposes we are using different types of the fuel. So what probable kind of the fuel we are used in a different purposes? So your answer may be the like cow dung, wood, coal, charcoal, petrol, diesel, or maybe the CNG. It means for different purposes we are using the different types of the fuel. We are familiar with the burning of a candle. What is the difference between burning of candle and burning of fuel like a coal? Though the different substances we are called as a fuel, but their burning pattern is very different. And if we take some example like a candle and a burning like a coal, what is the difference between this? So difference is that candle is burned with a flame, while coal is burned without a flame. Why this is happen? Because we know that candle contain the hydrocarbon wax, and this hydrocarbon wax is continuously evaporated. So that's why flame continuously catches the hydrocarbon wax, so that's why it burns with the flame. But in case of the coal, there is no any kind of the volatile substance present, so that's why there is no any kind of the wax or hydrocarbon substances present to catch a fire and burn with a flame. So that's why it is a burn but without a flame in case of coal. So what is the exactly mean of the combustion? What is combustion? A chemical process. It is a process in which substance reacts with oxygen and given off heat. This is called as a combustion. The substance undergoes combustion. It is said to be the combustible substance, and it is also called as a fuel. And the fuel may be the solid, liquid, or the gaseous one. Sometimes light is also given off during the combustion, either as a flame or it may be the glow. So with the related of this combustion, we will already discuss some activities. So first activity is that you have to collect some material like a straw, matchstick, kerosene oil, paper, iron nail, stone pieces, glass, etc., etc. Under the supervision of your teacher, try to burn each of these material one by one. If combustion takes place, then marks the material combustible. Otherwise, mark it as non-combustible. Can you name some more substances which are combustible and non-combustible? So I will provide you one table, and in that table you have to just simply tick which substance is combustible and which substance is non-combustible. For example, we have the wood. Tell me, wood, it is a combustible or non-combustible? Yes, it is a combustible. Paper, it is a combustible. Iron nail, it is non-combustible. Kerosene oil, it is a combustible. Stone piece, it is non-combustible. Straw, yes, it is a combustible. Charcoal, it is a combustible. Matchstick, it is a combustible. Glass, it is non-combustible. Just simply you have to tick in front of type of material whether it is combustible or non-combustible. Next, second activity. So all these activity are related with the fire, so you have to take a more precaution while handling all the combustible fuel. Fix a lighted candle on a table. Put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Observe what happens to the flame. Now remove the blocks and let the chimney rest on the table. Again observe the flame. Finally put a glass plate over the chimney. Watch the flame again. What do you observe in these three cases? Does the flame flicker off? What happens in these three cases? Does the flame flicker off? Does it flicker and give smoke? Does it burn unaffected? Can you infer anything at all about the role played by the air in the process of burning? It means you are performed in the activity. In three different cases, what is the exactly effect of air on the combustible substance? When you place a wooden block, when you completely remove wooden block, and when you covered that flame with a glass jar, what is your inference? What is your observation? So answer is that we find that for combustion air is required and the candle burns freely in case when air can enter chimney. In case B, when air does not enter the chimney, from below the flame flicker and produces smoke. In case C, the flame finally goes off because air is not available. So this is nothing but the simply observation in presence of air. Then it was air, but when we suddenly cut off the supply of oxygen, and in first case when there is an completely supply of oxygen to the combustible substance. So in this way, by three means we can do or we can write our inference or observation. Next, third activity, piece of burning wood. You have to take it like wood or charcoal on an iron plate or tawa, cover it with a glass jar or tumbler or a transparent plastic jar. Observe what happens. Does charcoal stop burning? After some time, can you think of the reason why it stopped burning? It means you already taken wood, charcoal and covered with a glass jar. So what exactly do you observe when you try to burn this wood or charcoal? Does they burn freely? So do this experience tell you that different substances catches a fire at different temperatures? It means it does not mean that all temperature catches a fire at the same temperature. So different substances catches fire at a different temperature. The lowest temperature at which a substance catches a fire, it is called ignition temperature. And we find that a combustible substance cannot catch a fire or burn as long as temperature is lower than its ignition temperature. It means if ignition temperature is low as compared to the substance ignition temperature, then substance cannot catch a fire. So from this activity we should know the term ignition temperature. So related with this, we have one substance, that is a matchstick. So we should know the history of the matchstick. The history of the matchstick is very old. More than 5,000 years ago, small pieces of pine wood dipped in sulfur. Which wood? Pine wood dipped in sulfur were used as matches in ancient Egypt. The modern safety match was developed only about 200 years ago. A mixture of antimony trisulfide, potassium chlorate, and white phosphorus. See, what are the chemical composition for the preparation of the matchstick? Antimony trisulfide, potassium chlorate, and white phosphorus with some glue and starch was applied on the head or the tip of the match made of suitable wood. When struck against a rough surface, white phosphorus got ignited due to the heat of friction. It means immediately white phosphorus present in a substance that catches a fire due to the collision, due to the friction. This started the combustion of the match. However, the white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users, because its ignition temperature is less. We can say that ignition temperature, it is near about 35 degrees Celsius. which is very close to our room temperature. So that's why these days the head of the safety matches contain only antimony trisulfide, that white phosphorus we completely omitted, antimony trisulfide and potassium chlorate. The rubbing surface has powdered glass and a little red phosphorus, which is much less dangerous as compared to white phosphorus. This is to be coated on the tip of the stick. When the match is struck against the rubbing surface, some red phosphorus gets converted into the white phosphorus. This immediately reacts with the potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion. So this is a process, very interesting and important chemical composition of the matchstick. You must know what exactly the substance we are using in the day-to-day life and what is the content present in that matchstick. Next, so with the related ignition temperature term is very important. It is the lowest temperature at which the substance catches a fire. It is called as ignition temperature. We find that combustible substance cannot catch as fire or burn as long as temperature is lower than its ignition temperature. Have you ever seen cooking oil catching a fire? When a frying pan is kept for long on burning stove, we know that kerosene oil and wood do not catch a fire on their own at room temperature, but if kerosene oil is heated a little, it will catch a fire. So this is due to the different substances has different ignition temperature depend upon its what is the ignition temperature of that substance. But if wood is heated a little, it would still not catches a fire. This is a difference. Kerosene oil catches a fire, but wood cannot catches a fire. Does it mean that ignition temperature of kerosene oil is lower than that of the wood? Does it mean that we need to take a special care in storing the kerosene oil? Yes. These are some questions based upon the ignition temperature. Can we take a precaution while handling the kerosene oil? Yes, we should take a care, because its ignition temperature is less and it can catch a fire very immediately. So that's why. And the following activity shows that it is essential for a substance to reach the ignition temperature to burn. So related with this one activity is there. Make a 2 paper cup. By folding a sheet of paper, pour about the 50 ml of water in one of the cups. Heat both the cups separately with a candle. What happens to the empty paper cup? What happens to the paper cup which contains water? Does water in this cup become hot? What do you observe? So this is a question. So what is your observation? You can observe if we continue heating the cup, we can even boil water in the paper cup. Can you think of an explanation for this phenomenon? The heat supplied to the paper cup is transferred to the water. Still we are heating paper cup, but all the heat gained by the paper, it is transferred to the water through the conduction. So in the presence of water, the ignition temperature of paper is not reached, hence it is not burned the paper cup which contain of water. It means that ignition temperature of the paper which contain water is increased. So that's why this paper it is not burn with flame, or it cannot burn at all. But empty paper it can easily catches a fire. Next part of the topic is inflammable substances. The substances which have very low ignition temperature and can easily catches a fire with a flame is called inflammable substance. Some examples of inflammable substances are like petrol, alcohol, then LPG or CNG, etc. How do we control a fire? When a fire brigade arrives, what does it to do? It pours water on the fire. We know that they are simply pour water. Why? Because water cools the combustible material so that its temperature is brought below its ignition temperature. and this prevents the fire from spreading. Water vapor also surround the combustible material, helping in cutting off the supply of air so that fire is extinguished. So this is one of the method through which we can control fire. You can see in this way a fire brigade, in their action they can simply pour water over the flame. So what are the requirements to start a fire? You have learned that there are three essential requirements for producing fire. Can you list these three requirements? Yes, these are fuel, air, and heat. So air is required to supply of oxygen. Heat is required to supply or increase the temperature of the substance beyond its ignition temperature. Fire can be controlled by removing one or more of these requirements. The job of fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel. Notice that the fuel in most cases cannot be eliminated. If, for instance, if building catches a fire, the whole building is the fuel. It means there is a choice is that you can simply remove the combustible substance. But if a fire catch by the big building material, then it is not possible to remove or to replace one building from one place to the another place. It is not possible. So that time we should have different methods, different idea, that is a fire extinguishers. The most common fire extinguisher, it is a water, but water works only when things like a wood and paper are on fire. If electrical equipment is on fire, water may conduct electricity and harm those trying to douse the fire or extinguish the fire. Water is also not suitable for fires involving oil and petrol. So do you recall that water is heavier than oil? Yes. So it sinks below the oil and oil keeps burning on top. We know that density of water is more, so that's why it is present at the bottom, and that oil and diesel or kerosene, it is get suspended at the top. For fires involving electrical equipment and inflammable materials like the petrol, CO2, that is a carbon dioxide, it is the best extinguisher. So CO2 being heavier than oxygen covers the fire like a blanket. Since the contact between the fuel and oxygen it is cut off due to the supply of carbon dioxide, so the fire can easily be controlled. The added advantage of carbon dioxide is that in most cases it does not harm the electrical equipment. How do we get the supply of carbon dioxide? It can be stored at high temperature as a liquid in cylinders. In what form is the LPG stored in cylinder? Obviously in a liquid form. When it is released from the cylinder, carbon dioxide expands tremendously in volume and cools down the temperature. So it not only forms a blanket around the fire, but it also brings down the temperature of the fuel. So that is why it is act as an excellent type of fire extinguisher, that is a carbon dioxide type fire extinguisher. Then types of combustion: bring a burning matchstick or a gas lighter near a gas stove in a kitchen, turn on the knob of the gas stove. What do you observe? We find that gas burns rapidly and produces heat and light. So this type of combustion, it is called rapid type of combustion. So what are the different types of combustion? You can see the substances like the phosphorus, which turn in air at room temperature. The type of combustion in which material suddenly burst into the flames without the application of any apparent cause, it is called spontaneous combustion. It means in the spontaneous combustion we are not heating or burning any kind of substance, but substance it can catch fire on their own. Spontaneous combustion of coal dust has resulted in many disaster fire in coal mines. Spontaneous forest fire are sometimes due to the heat of the sun or due to lightning strike. However, most forest fires are due to the careless of the human beings, it is important to remember that campfire must be completely extinguished before leaving a forest after a picnic or visit. We generally have the fireworks on festival days. When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light, and sound. A large amount of gas formed in the reaction is liberated, and such a reaction is called as explosive combustion, or explosion. Explosion can also take place if pressure is applied on the cracker. So that's why we can say that there are three types of combustion. One is a rapid combustion, second is a spontaneous combustion, and third one it is a explosion combustion. Then what is a flame? Observe an LPG flame. Can you tell the color of the flame? What is the color of the candle flame? Record your observation and mention whether and burning the material forms a flame or not. So this is type of the candle flame. Hold a glass tube with a pair of tongs and introduce its own one end in the dark zone of non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube. Do you see a flame? If so, what is it that produces a flame? Notice that the wax near the heated wick melt quickly. You can see in this way. The substance which vaporizes during burning give flames. For example, kerosene oil, molten wax rise through the wax and are vaporized during burning and form flames. Charcoal, on the other hand, does not vaporizes and so does not produce a flame. So in activity 5, could the vapors of the wax coming out of the glass tube be the cause of the flame produced? When the candle flame is steady, introduce a clean glass plate or slide into the luminous zone of the flame. Hold it there with a pair of tongs for about 10 seconds. Then remove it. What do you observe? A circular blackish ring is found on the glass plate or slide. It indicates the deposition of unburnt carbon particles called as a soot present in the luminous zone of the flame. Hold a thin, long copper wire just inside the flame for about 30 seconds. Notice that the portion of the copper wire just outside the flame gets red hot. Does it indicate that the non-luminous zone of the flame has a high temperature? In fact, this part of the flame, it is the hottest part of the flame. You can see this is the structure of the flame. Hottest part called as outer zone, moderately hot called as a middle zone, and least hot it is called as innermost zone of unburnt wax. What is a fuel? Fuel, it is nothing but the heat energy for the domestic purposes and the industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. A good fuel is one which is readily available and it is a cheap one. It burns easily in air at a moderate rate. It produces large amount of the heat. It does not leave any residue after burning, and there is probably no fuel that could be considered as an ideal fuel. We should look for a fuel which fulfills most of the requirements for a particular use. Then fuel efficiency. Suppose, what is meant by the fuel efficiency? Suppose you were asked to boil a given quantity of the water using a cow dung, coal or LPG as a fuel. Which fuel would you prefer? Give your reason. You may take the help of your teacher. Do these three fuels produces the same amount of heat? The amount of heat energy produced on complete combustion of 1 kg of fuel, it is called as a calorific value. So the calorific value, it decides how much amount of the heat energy released by the particular type of the fuel, and this calorific value we can consider when we take 1 kg of the fuel. Calorific value of the fuel, it is expressed in a unit called as a kilojoule per kg. So these are some calorific values of different fuels: wood, coal, petrol, kerosene, diesel, methane. Among them, hydrogen, it is a substance or fuel which indicate the highest calorific value. Then burning of fuel leads to harmful product. What type of the harmful products are get released while burning any kind of the fuel? Carbon fuels like the wood, coal, petroleum releases unburned carbon particle. These fine particles are dangerous pollutant causing the respiratory diseases like asthma. Incomplete combustion of these fuels gives the carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in closed room. So the carbon monoxide gas produced can kill persons sleeping in that room. So that's why it is a very dangerous gas. Combustion of most fuels releases carbon dioxide in the environment, and increasing concentration of these gas in air believed to cause global warming. Last harmful product, burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas. Moreover, petrol engine gives off gaseous oxides of nitrogen like NO, NO2 and oxides of sulfur like SO2. They can dissolve in the water to form an acidic rain, and such a rain it is called as acid rain, which is very harmful for crops and buildings. Last point, deforestation and global warming. For centuries, wood has used as domestic and industrial fuel, but now it has been replaced by coal and other fuels like LPG. In many rural parts of our country, people still use wood as a fuel because of its easy availability and low cost. However, burning of wood gives a lot of smoke which is very harmful for human beings. It causes respiratory problems. Also, trees provide us with useful substances which are lost when wood is used as a fuel. So moreover, cutting of trees leads to the deforestation, which is quite harmful for the environment. And last, global warming. It is the rising temperature of the atmosphere of the earth. This result, among other things, in the melting of polar glaciers, which leads to a rise in the sea level, causing floods in the coastal areas. Low-lying coastal areas may even be permanently submerged underwater, and the use of diesel and petrol as a fuels in automobiles is being replaced by CNG, and this CNG used because of harmful product in the small amount, and CNG it is very cleaner fuel as compared to others. So this is nothing but the revision on topic combustion and flame. In next video lecture we will see next topic. Okay, take care.